Alrighty guys, this is lesson 5.6, last lesson of the unit. We're starting off with a warm-up. As per usual, you should have started this, you should be done, and you are now watching the video to see if you got it all right. So we're solving by elimination, we're not solving by substitution, so that means we need to choose one of these variables and make it the same but opposite in the two equations. So we can make the y same but opposite or the x same but opposite. So I'm going to choose the x here, so I'm going to multiply the whole bottom here by 7. That's going to make it the same. So then I'll have 7x plus 14y equals 21 on top, and then negative 7x plus 49y equals 42 on bottom. Now when I add them together, we're going to get 63y equals 63. Then I divide by both sides by 63, so y equals 1. Okay. Now that I know that y equals 1, I go back and I plug it in. Negative x plus 7 times 1 equals 6. Okay, so negative x plus 7 equals 6, minus 7, negative x equals negative 13. So x divided by negative 1 divided by negative 1, x equals 13. So your answer is 13, 1. Okay? You have to know how to solve by elimination. You have to know how to solve by elimination. Okay? We make one of the variables, not two, but one of the variables the same but opposite. We add them together to cancel out that variable. You end up with one variable. You solve for that variable. You plug it into one of the previous equations, and we get our answer. Both coordinates, we get a coordinate. Both x, y, we get the coordinate. Okay? All right, on to our final lesson. Here we are. So it's 5.6. Go ahead and turn to 5.6 in your notes. Graphing linear inequalities in two variables. Okay, so before we start talking about graphing, we're going to talk about whether an ordered pair is a solution of the inequality. So the way we do this is similar to how we tested if it was a solution in a system of equation. You're just going to plug in this coordinate in here. So this is your x and this is your y. So we're going to have here 2 times negative 1 plus 9 is less than negative 3. Let's see. So that's negative 2 plus 9 is less than negative 3. That is 7 is less than negative 3. That is not true, so it's not a solution, right? If it's not true, it's not a solution. It's not true, okay? On the right here, same idea. So we have an x, we have a y, we're going to plug them in. So 2 minus 3 times negative 2 is greater than or equal to 8. So 3 times negative 2 is 6, negative 6, but it's a double negative here, so it's going to be 2 plus 6 is greater than or equal to 8. 8 is greater than or equal to 8. Is 8 greater than or equal to 8? Yes. Solution. Okay? So if it's true, it's a solution. If it's not true, it's not a solution. You just ask yourself, is this true? Is this not true? Okay, so how do we graph these? How do I graph this, for example? How do I graph this? How does that look? Well, the graph of a linear inequality in two variables shows all the solutions of the inequality in a coordinate plane. So here's an example. We have here y is less than 2x, and all solutions of y is less than 2x lie on one side of the boundary line, so all down here. The boundary line divides the coordinate plane into two half planes. The shaded half plane is the graph of y is less than 2x. So think about it like this. This line right here, that's kind of like y equals 2x right here. Okay? And then, well, why is it dotted? It's dotted because we are drawing y is less than 2x, and when we say less than, we don't include those values. So we do this dashed boundary line whenever it's a less than or greater than, and we do the solid boundary line whenever it's less than or equal to or greater than or equal to. okay? And then we want, if we read this, we want all the y values that are less than 2x. So less than, like those are below, right? These are all the values that are below 2x. So that's why this region is shaded. Okay, so essentially, like the way, we'll do this in a moment here, the way that we graph linear inequalities is you kind of graph it just like you would a regular equality, but then you have to choose, is it dashed or is it solid? And then you have to choose, am I shading above or am I shading below? That's it, okay? All right, let's do a practice. I think when we do practice, it'll make more sense. So before I even begin here, let's decide dashed or solid. Let's get in that habit. Let's decide dashed or solid. So look at this. Is this going to be dashed or solid? It's going to be dashed, okay? So I'm going to say ahead, this is going to be dashed, okay? Now, we need to graph this like we would a regular equation. So that means we need to get y alone. So let's get y alone. So negative x plus 2y is greater than 2. Let's get x alone. So get y alone. We're going to add x to both sides. 2y equals 2 plus. So I'm getting a bad habit here. 2y is greater than 2 plus x. Okay? Then we divide both sides by 2. By 2. Y is greater than 1 plus 1/2 x. Okay. So that means my y-intercept is 0, 1, and my slope is 1/2. Okay, so we're going to go here. We're going to go 0, 1. We're going to go up 1 over 2. We have up 1 over 2. Rise over run. Up 1 over 2. But when I connect the dots, because it's a dashed line, I'm going to be I'm not going to connect everything. I'm going to do little dashes. Okay, like that. We'll still have the arrow there and the arrow there. Now I want all the y values that are greater than this. So greater, is that above or below? Greater, what's above? So I'm going to shade this region above. Okay, sorry, ignore this little mistake here. But you're going to shade this region that's above. Okay. All right. Let's do a couple more practice, and then you guys will do some by yourself. And that will be the end of Unit 5. Okay. So what are y is less than or equal to negative 3? So remember, do you guys remember what y equals negative 3 looks like? Remember that? Remember that from Unit 3-4? That's a horizontal line. Y is always negative 3. So let's go ahead and draw that. 1, 2, 3. That's just a horizontal line. Y is always negative 3. That's what that's saying. All right? So if we want y is less than or equal to negative 3, well, what are all the y values that are less than that? Well, they're all down here. All right? That's less than. Okay, then we're going to write an equality that represents the graph. So first we just need the equation of this line. Well, so I'm going to write y equals mx plus b. Let's get the slope and the y-intercept. So slope is, we're going right 2 down 1, so it's negative 1/2. Because we're going down 1, so down 1 and then right 2. And then my y-intercept is negative 2. So my b is negative 2. So this is y equals negative 1/2 x minus 2, but you're not done. That's not the equation. It's not y equals. That's the equation of this line, but this graph, because we're shaded this region, we're shading below, so we need to say y is less than or equal to negative 1/2 x minus 2. That is your answer. Okay? All right, I hope this is making sense. Can you try this one by yourselves? And I'll give you the answer in a moment once you've tried it. Okay? All right, so we need to, I hope you've tried it. Now we're going to do it. So we need to get y alone. All right? So get y alone, I'm going to subtract 5x from both sides. I'm going to get 3y is greater than or equal to negative 30 minus 5x. And then I'm going to divide everything by 3. So y is greater than or equal to negative 10 minus 5/3 x. Okay. This is maybe not ideal for this graph, but we do have negative 10 on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we would be going, right, down 5, right 3, so 1, 2, 3, 1, 2, 3, 4, 5. We're kind of like down here, but we can go kind of work our way left by going 1, 2, 3, 1, 2, 3, 4, 5. Okay. So we have this line, roughly, and we want greater than or equal to, so we're going to shade the region above because it's greater than. We want the y values that are above that. Okay? All right. So again, try these, and then I'll help you out. All right. So as you can see here, these are all like really similar. In fact, like they're all written the same way here. The only difference is what's less than, what's greater than. But since they're all written the same way, if we just solve one of them, we'll know what the other ones are. So let's just get y alone for one of these, and then we'll be happy. So for this one, let's subtract 3x from both sides. And we will get negative 2y is less than or equal to 6 minus 3x. We're going to divide both sides by negative 2 by negative 2. And we'll get y is greater than or equal to negative 3 plus 3 halves x. So just be careful here because we divided by that negative, we got to switch the sign, right? Remember that rule? So we're saying greater than or equal to negative 3 plus 3 halves x. So that would have to be C. Right, that would be C. So this one here is C. I'm going to, again, give you a moment. If you haven't done it yet, do the rest, and then I will give you the answers to these. Okay? All right. So this one, we would end up with, after we solve this, y is less than negative 3 plus 3 halves x. So that has to be D. After solving this one, after solving this one, we'd end up with y is, after solving this one, we'd end up with y is greater than negative 3 plus 3 halves x. So this one is going to be A. This one we'd end up with y is less than negative 3 plus 3 halves x. So we'd end up with C. No, I am tired, guys. I am a little tired. This is D. And then this last one has to be B, right? We would end up with y is less than or equal to negative 3 plus 3 halves x. Okay? All right, so just you solve each one individually for y, and then you're able to match it to which one it should be here. Okay? And by solving it this time here, we would be able to that would help us figure out what it would equal here. But you should just follow the same steps we did in the first example to get those answers. Okay. 3, right inequality represents this graph, so let's take a look at it. This is our axis right here. It's got a y-intercept at b, so my b is 1. Oh my goodness. It's got a y-intercept here at 1, so b equals 1, and my slope is 2, so my m is 2. So the equation of the line is y equals 2x plus 1. But it's not an equation. It's going to be an inequality, and because we're shading above and it's dotted, it's got to be y is greater than 2x plus 1. All right, now delta time. To work on the delta, get the practice in, and if you're done with that early, you can get the practice test from Mr. Lee. Thank you so much. Bye-bye.